Hello everyone, my name is Ganesh from Computer Science Department. Currently, I am pursuing my final year in Sri Venkateswara College of Engineering, Bangalore. I am here today to discuss about my seminar topic, which is titled as Greenhouse Agriculture Using IoT. Contents of my presentation include introduction, abstract, literature survey, methodology, result, conclusion, and references. Without any further ado, let's get into the introduction. Now, greenhouse agriculture is an important method of food production that enables farmers to grow crops in a controlled environment, protected from external factors such as weather, pests, and diseases. The potential of greenhouse agriculture can be further enhanced by leveraging the power of IoT. IoT provides a platform for smart agriculture, enabling farmers to monitor and control various environmental factors that includes temperature, humidity, light intensity, and CO2 levels. This technology allows farmers to collect real-time data, which they can use to make better decisions and optimize their farming practices. The integration of IoT with greenhouse agriculture can lead to improved crop yield and quality, reduced resource consumption, and a more sustainable future for agriculture. This paper aims to explore the benefits and applications of IoT in a greenhouse agriculture. The continuous growth of world population, environmental change, industrialization, the arable land over the globe is decreasing every year. Therefore, the demand and requirement for hygienic food and crop yield have been growing continuously. It is expected that more cropland and water will need to meet the future food demands globally. Furthermore, other challenges such as abrupt changes in climate, lack of labor, and water scarcity spiral in pressure on agriculturists and farmers. Greenhouse farming is one of the best alternatives to overcome the food crisis as well as to ensure the sustainability of socio-ecological. At present, greenhouses have become one of the ideal farming methods in the agricultural world. The emerging IoT technologies provides a high potential for innovative methods and smart solution development, which can transform the agriculture sector in all aspects. The motivation is to investigate the IoT-enabled greenhouse research trends and various open issues that are vital to transforming greenhouse farming technologies. In the conventional greenhouses, climatic variables and other growing methods were depending upon the cultivator's assessment and demand for the number of growers. The deployment of wireless sensor network enables climatic data to be gathered and distributed for understanding and monitoring the internal system of the greenhouse, but there is a need to handle several other features which can cause significant disruptions to the grown plants. The eradication of these issues can be done through a precise system that helps to automate the monitoring and control methods for smart greenhouse. Thus, integrating the IoT with a greenhouse to convert it into a smart and automated greenhouse is considered to be one of the foremost and ideal solutions. Next, we'll be looking at the abstract. Greenhouse agriculture is an important and efficient method of food production, and its potential can be further enhanced with the use of IoT. The greenhouse is one of the sustainable forms of smart agricultural farming. It is considered as an alternate method to overcome the food crisis, which is generated due to high population growth, climate change, and environmental pollution. The advancement of IoT has introduced smart solutions to automate the greenhouse farming parameters such as plant monitoring, internal atmosphere control, and irrigation control. Although this method supports off-the-season crops within the enclosed area even in severe climatic zones, it has required to efficiently control and manage the crop parameters at a greenhouse in a more precise and a secure way. Through the use of sensors, actuators, and network devices, IoT systems can collect and analyze data on temperature, humidity, light levels, soil moisture, and nutrient levels. This data is then processed by a centralized system that uses algorithms to make decisions on the appropriate actions to be taken to optimize plants' growth and yield. Additionally, IoT can facilitate the use of precision agricultural techniques, allowing farmers to tailor their practices to individual plants or crops. Next comes the literature survey. These are the few journals which I have referred for the topic. The first journal is titled as Design and Implementation of an IoT based greenhouse monitoring and controlling system. The author describes it as a journal that includes IoT based ecosystem for agricultural area, which includes four major components such as IoT device, communication technology, internet, and data. This is a cost effective design and also an important consideration in IoT based monitoring and controlling system. The second journal is titled as Design, Construction and Testing of IoT based automated indoor vertical hydroponics farming testbed. The author describes this as it provides an overview of the existing literature on hydroponics farming, IoT based automation, and vertical farming systems. The author also discusses the advantages and disadvantages of different hydroponic systems such as deep water culture, nutrient film technique. The third journal is titled as the Security and Privacy for Green IoT based Agriculture Review Blockchain Solutions and Challenges. The author describes it as with the inclusion of various security and privacy threats, including attacks on sensors, network level attacks, and data breaches. They also review the existing security solutions such as authentication, encryption, and access control, and also the highlighting their limitations and challenges. Next, we'll be continuing with the methodology. This methodology has two methods. The first one is the smart greenhouse. A packed loop is formed in the greenhouse and plants are protected from the external climate. A safe situation is produced from growing crops and it shows a high significance in the varying climatic circumstances. This process lets the growers to optimize, observe, and regulate the cultivation of sensitive crops to maximize their crop yield while maintaining its quality for the end product. In this, the sensors must be installed in the greenhouse to monitor the environmental factors that affect the plant growth. These sensors can include the temperature sensors, humidity sensors, light sensors, and CO2 sensors. The data collected from these sensors can be stored in a cloud-based platform for analysis and decision making. A decision support system must be implemented to analyze the data collected from the sensors. The decision support system can use algorithms and machine learning techniques to provide insights and recommendations to the farmer, such as adjusting temperature and humidity levels. The control system must be established to enable remote control and automation of the greenhouse environment. This control system can include devices such as actuators, water pumps, and fans that can remotely control through a mobile application. The integration of precise agricultural techniques with the smart greenhouse methodology can provide more personalized and targeted treatment for individual plants or crops. This can include variable rate application of the fertilizers and pesticides based on the crop maturity. Data analytics and visualization can be used to provide farmers with a better understanding of the crops, growth, and performance over time. This can help in identifying trends, patterns, and anomalies in the data, allowing farmers to make more informed decisions and optimize their farming practices. The second method is the hydroponics greenhouse. It is a cultivation technique using water instead of soil. It shows that soil is not vital for plant cultivation. Only the vital minerals, nutrients, and adequate pH are required within a specific range inside the water. Hydroponics is a type of greenhouse agriculture that involves growing plants in a soilless medium with nutrient-rich water as the primary source of nourishment. The integration of IoT technology can help to optimize hydroponic greenhouse agriculture by providing real-time monitoring and control of environmental factors. The methodology for implementing the IoT technology in hydroponic greenhouse agriculture involves several processes. These include that the sensors must be installed to monitor the pH level, electrical conductivity, temperature, and nutrition concentration of the water in the system. This data can be collected and stored in a cloud-based platform for analysis and decision making. The sensors related to electrical conductivity are standardized using low, high, and dry electrical conductivity adjustments by using solutions having dissimilar electrical conductivity levels. The actuators are driven by the system and supply the required amount of hydroponic fluid that is mentioned in the received information. A control system must be established to enable remote control and automation of hydroponic system. This can include devices such as water pumps, nutrient dosing systems, and temperature controllers. The integration of precision agriculture techniques can help to further optimize hydroponic greenhouse agriculture. This can include using data analytics and visualization to identify trends and patterns in the data and adjust the hydroponic system accordingly. The use of IoT technology can also help to improve the sustainability of hydroponic greenhouse agriculture by reducing the water and nutrition waste. The sensors can detect changes in the water quality, and the decision support systems can adjust the nutrient dosing to prevent over fertilization or under fertilization. The integration of IoT technology can help to optimize hydroponic greenhouse agriculture by providing real-time monitoring and control of environmental factors, which enables precision algorithm techniques and improving sustainability. This can also lead to an improved crop yield and quality, reduced resource consumption, and a more sustainable future for agriculture. Next comes the result. The use of Internet of Things technology in greenhouse agriculture has numerous benefits, including increased efficiency, productivity, and sustainability. IoT technology allows for the automation and monitoring of various aspects of greenhouse operations, which includes the climate control and fertilization. One of the advantages of using IoT in greenhouse agriculture is the ability to collect and analyze large amounts of data in real time. This data can be used to optimize crop growth, reduce waste, and save energy. IoT technology can help greenhouse farmers make informed decisions by providing them with insights into crop growth, yield, and quality. This can be done through the use of predictive analytics and machine learning algorithms that can identify patterns and make recommendations based on historical data. IoT technology can also help greenhouse farmers reduce their environmental impact by minimizing water and fertilizer usage. This can be achieved through the use of smart irrigation systems that are designed to deliver water and nutrients only when and where they are needed, reducing waste and minimizing the risk of over-fertilization. By integrating IoT devices into a greenhouse systems, farmers can gather real-time data on a variety of environmental factors such as temperature, humidity, light, soil. IoT sensors can monitor the conditions inside the greenhouse and adjust environmental factors to optimize the plant growth. This can result in higher crop yields and better quality produce. IoT sensors can monitor soil moisture levels and automate irrigation systems to conserve water and reduce waste. IoT technology can also automate tasks such as monitoring and adjusting the growing conditions, freeing up labor for other tasks. IoT sensors can track the growth and development of crops, providing valuable data for tracking and traceability purpose. IoT technology can help reduce energy consumption in greenhouse agriculture by automating lighting and ventilation systems. This can also result in significant cost saving for farmers. Moving forward into the next slide, we'll be looking into the conclusion. The current status of the research has indicated that it was feasible to remotely monitor the greenhouse parameters such as CO2, pH, moisture content, humidity, temperature, and irrigation by using IoT sensors and devices. Furthermore, various traditional and developed cultivation techniques are discussed which can help the growers to understand the technological structure of a greenhouse. Several important dimensions of IoT greenhouse farming, top technology for instance, and success stories, performance metrics have been set by the stakeholders. This article also considers many IoT-enabled greenhouse open issues and security challenges with future research directions. Government and many big organizations have started investing to develop new smart greenhouse farming techniques by using IoT. The use of IoT technology in greenhouse agriculture is a promising development that has the potential to transform the way we grow crops. IoT technology enables farmers to automate and monitor various aspects of greenhouse operations, providing real-time data that can be used to optimize crop growth, reduce waste, and save energy. By using predictive analytics and machine learning algorithms, farmers farmers can make informed decisions based on data. And also, the IoT technology can help greenhouse farmers reduce their environmental impact by minimizing the fertilizer usage. In greenhouse agriculture, the integration of IoT technology can revolutionize the way we approach food production and provide a more sustainable future for generations to. Next comes the references. These are the few references they have referred for the topic. Thank you for watching this video. Have a great day.